Did you ever climb a mountain? I don't mean a regular easy hike. I mean a serious one like Denali or Kilimanjaro or Fuji. You get up early. It takes all day, maybe multiple days. It's really hard work. By the time you get up to the top, it's amazing. But getting there was most of the journey. It's what you experience. It's how you are changed. You're a different person when you reach the summit. Now, when you reach the top of the mountain, imagine once you get up there, there's some helicopter that buzzes in with some billionaire bastard who drops on the top of the mountain, takes a selfie, bounces off. He also got to see the actual top of the mountain, the peak, but he didn't get to climb it. Now, this may seem like a weird hypothetical, but this is the reality for writing code these days, where we all have the choice of being that billionaire bastard. With the power of AI coding, we can just drop on the top of the mountain. We don't have to figure out how to write the code. The machine will do it for us. That's the journey I want to dig in today, whether or not we should still be climbing mountains, what comes next when everyone can get to the top of the mountain on their own helicopter. I'm Jeff, and this is Iterative Refinement. So, for those of you who have been watching this channel, in the previous episode, we talked a lot about who's writing code. Who is the person who's contributing to an open source repo? Are they a good egg? Are they a person that you should trust? Well, in this episode, we're going to talk a little bit less about is the person the right one, but do they in fact know the right things? Are they in fact really competent at what goes on in your repo, in your project, in your technology? We're going to talk a little bit more about open source versus enterprise than we did last time. Now, to get started on this topic, we have to talk about what you need to know to write code in the first place. Who is actually good at writing code? Who's the strong contributor on your team, on your project? Because this is something that's really changing quite fast. Our definition of who is good and why they're good is a really rapidly moving topic in the age of AI coding. But I'm going to present to you my view, which is that there are some unique things, some specific stuff about how your technology works, about how your code for your team on your project works that you know that are in your head because you're an expert, because you're the tech lead, because you've been there for years. And these are oftentimes the unwritten rules. But you can find them by sitting around, by shipping features, by learning stuff from reading the docs, and from going back through the history. I've done a bit of research on what you might actually have in your head, so I'll share a little bit of that from some recent work, pulling from a talk that originally presented at QCon London. So here's some basics here. Now, when you start to mine what's going on inside of a repository, what are some of the things you're going to find? Well, for example, when you look across a bunch of open source repositories, you'll find these patterns that are not necessarily written up explicitly, but occur again and again and again. So here's a really good one called version synchronization. And so in this sample of dozens of repos that we studied here, we found that a lot of these projects have this version where there's some version that has to be kept in sync that isn't just one number in one place, but actually occurs in multiple spots throughout the repository. And it's just a concrete technical constraint that you have to update that in several places at once. Otherwise, you don't have a sound merge. Again, this isn't really in tests, and so you have to discover this yourself. This is part of what it means to be expert. Here's another example from the LangChain project. So LangChain is a really unique project in terms of how really broad it is. It's trying to be this place that allows you to bring every sort of connection you would want together into building your agents, which is a really ambitious mission. But what that means is that they end up having a lot of integration complexity. And so in particular, they don't really know what dependencies you might have installed or not, and so they use this sort of lazy dependency import pattern. And the way that they do it involves actually 6 different rules, which are documented to different levels, many of which have to be inferred. And if you don't do every single one of them and isolate your dependency in the right way, your PR is going to get kicked back because it's wrong for LangChain's users. And this sort of complexity is really quite intrinsic to the problem space of what they're building. This is another example of a rule you would have in your repo that you'd have to be an expert on to really know. Okay, now I don't want to just talk about Python and ML workloads alone, because I think that can sometimes feel like people are only talking about one style of code. And so we'll try to compare the AI world into something that is really quite a bit more traditional. And so VLLM is a Gen AI inference server commonly used with large language models. It is written in Python, but let's compare it up to Rust, which is really more of a linter that is written in Rust. So in Rough, what we're really doing is something quite different than what we're doing in VLLM, but there is this same sort of software development pattern which occurs, which is you need to register new components in a very affirmative way within a given data structure, and there's really like no source code level way of discovering this in the that this rule exists in both of these repos, but through interactive learning of the repo, you can actually pull this knowledge out from the history of the committers. This is I found this work in a research project that I led with my team, and it took a lot of LLM power research just to discover this knowledge. But these patterns occur and again, and they are repo specific, even if the patterns match. And they do exist in all projects of all types. Last one I'm going to present here is another one from the space of fast-moving Gen AI type projects. In this case, this is the Axolotl project, which is a fine-tuning repo by Wing Lian. It does a lot of integration of very complex components, many of which come from the Hugging Face ecosystem. In this particular case, there's a validation function, which is just this really, really weird function that you probably don't have in your head when you write the feature, because it has all of these rules they learned the hard way through trying to plug all of the different systems together. And make them work. And in this case, there's an instance of silent corruption that you can get in your data if you don't, in fact, have a valid configuration. These config properties may look correct in isolation, but when used together, they will silently corrupt your code, which is a hugely destructive pattern. So these are all over all sorts of code bases. When we studied this across a range of different sorts of repositories, we found that, sure, there are some basics out there. There's just general good software engineering type rules that everyone needs to know. There's some things that are domain specific, maybe they're just commonly true of, say, Go projects or Rust projects, but a lot of rules are unique to that repo. I would purport to say that this is true in enterprise code bases as well. There's lots of specific things that are true about your technology that are true because of what it is uniquely. And so that's the mastery that we're talking about developing when we need to have our expertise. Are we in fact good at this code base? Well, it matters if we have this stuff in our head. Okay, let's move forward to understanding now how do we interact with that in the modern code base these days. So, all right, so in a world where all of these different projects are moving at a really rapid clip due to the pace of development these days in Gen AI code, what you're going to find is that a lot of the latest PRs you're going to find in open source, and perhaps increasingly inside the enterprise you might find yourself in, are written by Gen AI tooling, that they are code-genned. And so how do we know that the person who wrote them actually has those rules in their head, that they applied those rules when they made the choices? Even if they're, say, driving an LLM tool, whether they're in Claude Code, they're in Codex, they're in Cursor, did they in fact understand the constraints of what they're building? Well, I think to me, this really drives the question of should this PR be merged or not, is really based on whether or not they have that expertise, they apply that expertise, and then raises the question of how could you know? And so I'm going to walk you through some work that I and my team worked on a project called PEAK. Now, PEAK stands for Proof of Effort and Knowledge. And what we're really trying to do is recognize that there is that deep expertise that sits inside every expert that needs to be demonstrated in some way so that you can know for a fact that someone is in fact truly bringing to bear their knowledge of the things that make a merge to a particular PR sound and good. So let's dig into that. So this is how we're going to interact with PEAK. So PEAK is today a command line utility. You don't need to install it directly. You can use it via UVX. We're going to start off by trying to evaluate a PR from scikit-learn. And so let me show you a little bit of what's the context of that first. So scikit-learn is a traditional machine learning library. It pre-exists the deep learning era. It's extremely battle-tested, has a ton of really powerful features. Now, let's look at this PR. Now, what are we looking at here? Well, This is a pretty complex issue. So we're in stochastic gradient descent, one of the most critical and central algorithms in all of machine learning. There's an issue with convergence where things can be undertrained. And this is a fairly deep dive sort of fix here. You can see that there's a fair bit of sophistication of what's being done here. And so this contributor up here has proposed a fix, and then it's going to take a lot of evidence and back and forth to figure out whether or not it's right. Now, I'm going to show you what the peak experience looks like for being able to see if this code was written correctly and understand what was in this person's head. So in Peak, again, we don't have to install. We can just use this via UVX. In this case, we're saying we're going to run on scikit-learn, and we're going to call this PR that we were just looking at. Okay? So I didn't show you this, but this actually offed for the first time against GitHub, because what it's actually going to do is it's going to say that I, Jeff, am the person who is filling out this particular piece of information. And it's also going to then cryptographically sign manifest so that we know who did this. So what Inside Peak is doing, what we're going to look at is what was our goal with this PR. So that, generally we're going to say, like, I don't know, make SGD better or something like that. Sure. Now, the rest of this is where things start to get really sophisticated, because there's this pretty complex model behind the scenes of trying to understand what changes did you make. What specifically is correct for this repository based on our understanding of the historical rules? And then how can we really validate that you're paying attention and engaged and actually the author of this work and understanding it? And so the questions can get incredibly detailed and specific, generated dynamically in response to what's in the code base here. And so we're talking about, in this case, we're validating things like serialization issues and is this a breaking impact? And so, like, I don't really have all the answers to this one because I didn't write this repo, write this PR. And so it's going to keep asking me deeper and deeper dive questions. And if I don't know the real answers, it's going to record them. Now, in this particular instance, it's going to just be scoring these things dynamically. And so let's see. We're talking about so the peak model is going to really work through like all of the different ways in which you've made design decisions and really try to get you to walk through and articulate your thinking. I find that it really challenges me to think about how I built something. And if you're not the author of this, if you've really kind of vibed this, if you don't have a deep understanding of the repo, peak questions can be really, really hard. Also, there's a little bit more of an adversarial framing here where sometimes folks are really just trying to vibe this stuff through. And so there is a little bit of work here to elucidate whether or not are you an easily steerable LLM just kind of going with the flow? Are we and so we inject in sort of counterfactual statements here that are that will trip up an LLM from time to time. Let's see. All right, and one more question is going to come out at the end here, and so. You can often find that in a peak interview, what you're having happen a lot of times is this sort of debate around how we've designed it. Why did you make that choice? How does it compare to the rest of the architecture? And I think these are the questions you often have with a human reviewer, with a tech lead who is the expert on this repo. All right. And so we've answered our questions here. Now, the number of questions the peak will typically ask you is proportionate to the complexity of the change you're doing, as are the sorts of questions that it digs into based on, are you doing something really big? Are you doing something really dangerous? What are the rules that apply? What is our knowledge of the space of the change? Okay, now let's look at some other sorts of repos and some other sorts of mergers someone might have. Let's try a different sort of thing. All right, let's jump to the other end. So scikit-learn's really, really battle tested. It's really pretty well established. Now let's go beyond and let's dive deep into the deep end of the weirdest and wildest part of Gen AI, which of course is the territory of openclaw. Openclaw is cranking with huge amounts of commits all the time. And very frequently people are building these commits in openclaw itself, and so they don't necessarily have a lot of human supervision of the changes in here. In this case, we have something which looks like it could be a legitimately strong sort of PR, but it says it's doing something about verbose limits, but it has a really, really broad scope of change. It touches RPC, 3 different UIs, tons and tons of changes. And so if we fire off peek on something like that, let's go back and do that now. So we're gonna pull down some work on claw. Yeah, so that's our matching one here. We can pull that up, and it's going to start to ask our question. So if our original intent was, say, reducing our verbosity, great, that's a good goal. But now it's going to get into what's actually in the code base and start to really tease out how we approach this. And did we in fact know what we did? And did we think about this? And so a lot of these sort of like scenario planning type questions, like what would happen if this went out and if things went wrong? What's the failure mode? Can you walk me through an outage? Do you understand the consequences here? I can tell you from direct knowledge of the openclaw project, this is not how they talk through stuff in this level of detail at the rate at which they're merging PRs. And so they're not actually going to do stuff like this. But you can see if you're actually trying to maintain a really high stable bar of quality, this is what you'd be doing. You'd be asking these questions. So I'm going to kill this one and I'm going to show you a different one. But we're going to stick with openclaw for just one more beat because it's fun. I like openclaw. They're exciting. They ship so much code. How about this bad boy? So this is a fairly non-trivial change. I don't know why it's built this way. The entire title of the PR is just okay, which does not fill me with confidence. It has 13 files changed. It staples on a bunch of tests on the side. It has some soundness to it, but I'm not confident that this is in fact something I should be using. So let's again fire up peak and see if we can pass through a peak instance on this one. And so in this case, we're going to be going to pull up here's our. Notice how high already the PR numbers are for openclaw. Openclaw was launched only in November, and it already has a huge number of PRs. We're in PR 43,142. So what was our goal? Is okay PR? I guess something. So it's maybe something test related. Maybe, I don't know. I guess. And now we're going to go back and mine through this. There's a lot of knowledge, and so we have to store a cache of what are all the rules of what constitutes good openclaw code. So let's see. Again, we're going to kind of reason through what would happen if this broke. And then, all right. Again, we're kind of trying to think about truly, like what's the steps that we're going to do here. Did we in fact take the correct approach? Blah, blah, blah. All right. And so now it's going to get a little bit pushy here, which I appreciate, which is that the PR template is empty. The title is okay. There's no technical context, which is, I think, LLM speak for like, what the hell, bro? What the hell? All right. So openclaw, particular vibe here. I'm not sure it's my vibe. I'm not sure it's everyone's vibe, but it is a vibe. It's a really important one. Let's just hit a couple more different sorts of projects to get a flavor for things, and we'll leave the territory of the claw-based software and go back to our regular exploration. All right, so here's what I think gives you a sense of like what's the real target here. When I try to understand from open source into enterprise, I often have to dive into something that has this level of non-triviality to it. So like what's actually really hard code to write, what's really hard code to review, to merge. This is the scipy project. You may be more familiar with, say, NumPy, certainly PyTorch. Scipy does some really sophisticated statistics. Everything is kind of a deep dive in scipy. It's all pretty mathy. It's all pretty hard. I have no idea what the correct code for this one is. If I dive into a peak session for something like this, it's really going to be quite challenging for me to answer. The LOC here is not large. We're seeing that there's really, really small amounts of changes here. But something that's really like quite maybe non-obvious to this. Have you written any .f files lately? What is .f? Well, of course, that's Fortran code. That's code that's older than me. That's code that's probably older than you. And so this is one of the big secrets that kicks around the PyData ecosystem is that we built all of this PyData infrastructure on top of older numerical libraries, and that we're still extending them. But it's really, really non-trivial to review this stuff because there's not a lot of people writing Fortran these days. And so the deep dive questions for a repo like this, it's not just going to ask me about math, it's going to ask me about Fortran. And so even though it's a relatively small line of code change, the peak questions are going to be pretty difficult. Okay, I'm bouncing over to another example. All right, now Our last example was a sort of proxy for really, really sophisticated, high consequence sorts of code bases that may look like what you're seeing in your enterprise. This one's really kind of at the boundary between, I would say, open source and enterprise. This is the crewai project. Now, crewai is an open source project. It has a lot of open source adopters, but it also has a commercial entity behind it, and a lot of their work is focused on enterprise automation via agents and things like that. This is an interesting merge here because, for one, um, it was definitely written by Claude. It signs itself as Claude in several places. And so being able to understand that as Claude is a co-author, you see emoji spam everywhere. So if this was in fact our repo, if we have to pass this, do we in fact know as much as Claude knew about this stuff? Well, I hope we do, but I'm not sure that we do. So let's try and fire up a peak session and see if we can get a sense of just how hard this might be for someone to answer if they were vibing this a little bit. So we will call this one up. Okay. So as far as I can tell, this was something about, what was this one about? So it's some sort of like crypto change, as far as I can tell, which is really pretty deep dive stuff to be going into, just fully vibing it. So there's some sort of crypto. It's being fired off. I don't know. Yeah. Okay. So, and then it's actually gonna test me and see. Okay, it fired off 8 questions here. This is probably as big as we let our budget get. So it does a lot of, like, it's pretty good to walk you through this one. It sees a lot of blast radius in the change of this one, which I think is fair. This is dangerous. Particularly if the author is in fact not an expert and leaned heavily on Claude in this one. So here we've got our first crypto question here, which is that we're implementing cryptographic tracing logic, and that it's wiring things up to a demo script, and really it's beginning to get down the rabbit hole of, hey, bro, maybe you don't know what you should have been merging here. I'm not sure if this is fully safe. I think these are really valid questions, and these are like the work that a maintainer team has to do in open source is also the work that a tech lead has to do in an enterprise. All right, one more example. This one is interesting. So, um, I guess this is a cost tracking feature. The project we're on here is the Goose project from Block. It's an agent harness used a lot for enterprise automation usage, fully open source, super pluggable. People do it to do all sorts of powerful things. But this one has just like a ton of LLM assumptions in it. The author said, made assumptions like four characters equal a token. We only need the last 20 models, blah, blah, blah. And so, if you drag this person through like a really in-depth review, would they know everything that they changed here? It's really kind of a big blast radius with a lot of open questions here. I'm going to tell you that we're not going to walk through this one because if you go back, that actually, even though the person's responding and clearly knows something about the process of it, the actual like author here is this guy who you may have come across before. It's Jack Dorsey, co-founder of Twitter and a Block. And so his PR is probably getting merged. Whether or not he knows this stuff here, I think in this case, if you actually read through the chat, he does know his stuff. But it really has some fairly like cheap and chipper assumptions within the ways that models LLMs and LLM services. And so perhaps if he were not Jack Dorsey, perhaps that would not get merged. Okay, so I want to give you a sense of like how people respond to systems like this. And so one of the things that people bring up in this approach is, well, is this in fact the right way to do this? Are you producing a spam filter? Are you trying to slow down people from vibe coding? The answer is right now there's actually like really quite an interesting dispersion of different attitudes out there within open source. So some people are actually really trying to move faster and merge more things, like the openclaw scenario, probably like the Goose one as well. Other people are really trying to stay rock hard, stable, just the most battle-tested they can be. These are people like scipy, numpy, scikit-learn. And both can coexist. One of the first things that we built for the peak feature was the ability to really do this by delegation and whitelisting and figure out who we're assigning this to. And so if you don't want to assign a PR review quiz to Jack Dorsey, then don't do it. But if you have a new rando who's showing up in your PR and just puts showing up in your repo and just puts okay as their PR title or body, maybe you should see if they know what they're building. I think these are all entirely reasonable questions. Um, I think the other really interesting thing here is that when you prove that you've done the work, that really addresses a really critical concern I hear coming up again and again, which is that we don't know who knows how to code anymore. We don't really know who has their stuff, who has spent the time climbing the mountain, understanding how each project works, building that expertise, and putting in the work. And so, one of the great ways that LMs like this can be used, the ones backing Peak, can be used to learn more about a code base and prove that you learned more about a code base. In open source, I don't know if this is going to become the way in which people think about, their new GitHub page with all those green squares. Well, since that's free now, because anyone can do a fully green brick wall with an LLM, well, you can't prove that you know all those things, and I think it's a missing spot. And so I do wonder if this is the best way to support people who are students, who are more junior and earlier in their careers. We're trying to prove that they're actually putting in the mastery, that they have put in the effort, and they have the knowledge. But a perhaps more enterprise and immediately commercially concerning question is, so what about the story of the CTO? The CTO who has, say, hundreds, maybe thousands of developers that they are responsible for. How does that person prove that their developers know what they're supposed to know, that they're contributing with expertise, that they're not just leaning back and letting Claude write all their code without ever making any choices? I think that's really an unsolved question. I don't see products in the market that actually solve that. Peak, I think, is an effort to do that, but really, I'm interested in the general open question: how, as we as engineering leaders, going to understand what our teams are really getting in their heads? What work are they doing to climb the mountains and develop that expertise? So that also brings into how people respond to work like this. So when I rolled out Peak to some folks, and some of the interesting responses were, there's at the most conservative end of things, while people are trying to keep things really stable, they're also really trying to reduce friction. So they want those exit paths. They want to be able to say, hey, we're not going to have Jack Dorsey do this one, or this guy actually is the creator of NumPy. We can let Travis just merge his thing. Other times, they really do want to think about how do they budget their time and not spend time on things like okay only titled PRs. But a lot of the people who are the most extreme, the most forward-looking, the fastest-moving folks, the claw heads and things like that. Well, what they really want is just speed, speed, speed. And so the idea that someone would stop and have to pass a quiz, I think, is really not exactly how they're thinking about this. Instead, what they're really thinking about is how can we move faster? How can we get past some of the old bad patterns? How can we drop repo level knowledge entirely? And so what I described in some of those patterns around here's how you config versions, here's how you keep things in sync. Many people are already treating as, well, actually, all of those things were anti-patterns. They were from the days before coding AIs, and I want to drop them entirely. That's just cargo culting, and we want to move forward. There's actually some really extreme examples out there right now of people taking those steps. I'll show you just a couple. So here's a really cool scenario here. Oops. All right, this is the Chart project. You may have heard about this one. This is a library that was built by one person and then eventually taken over by another person to maintain it. And at some point, that second maintainer decided to write a new version in a clean room fashion, taking the old test suite, writing a completely new version with LLM for the purpose of putting a new license on it and forking complete control of the future of that project. Really controversial example, but it's interesting to see that people are now actually importing and relying upon this new implementation, which the author's quite clear was written by Claude in a hurry, using really only the test suite as proof that it was built soundly. This, to some people, is the future, that we don't actually care that all of that knowledge was in the author's head so much as it was in a system that we could check against, and that a reasonable level of review was done at this point. It's a very extreme maximalist approach, and it really has interesting implications for the entire field. One of them is a sort of satirical project called Malice, which jokingly describes itself as clean room as a service, which says, hey, actually, you could just slap a new license on any bit of code that's out there in the world, because all you have to do is reverse engineer it from its test suite or from its specs. This is very, very tongue-in-cheek, but I think it's in fact happening at a huge, huge scale. The pattern that I hear from a number of people is that vendoring is back. Vendoring is the pattern of copying in your dependencies into your source tree so that you can make changes to them and do different things. This is something that LLMs really like to do, and it becomes a powerful way to put more control within the context window of your coding model. I think it's actually becoming really an interesting pattern, and it has really troubling implications for the future of open source, but is an exciting way to really think about full stack rebuilds of things that maybe were holding you back because there was some lower layer that was built in this weird way, and like you didn't really want to have to get into learning the Fortran to make this thing go fast. Um, the world's changing real fast. The last thing I want to connect this to is the org chart. So I spend a lot of time in rooms with senior engineering leaders, CTOs, VP Eng, technical leaders who really are responsible for whole organizations, and a lot of them are talking about team size. A lot of engineering leaders right now are getting pressure to shrink their team sizes to realize returns from AI investments. And the patterns that emerge from this is that teams that run really fast with AI code are oftentimes small and senior. And I think both of those things really matter for thinking about the future. And so the small thing means we may be really raising the bar on who makes it onto the team, who actually is that expert, who has that proven ability to understand what is good code, whether they're driving it via AI, whether they're doing a review, but they've got the expertise in their head. We know that they've climbed the mountain and they can actually deliver real impact. But then they're senior as a result most often. Most of the time, they learn that the hard way through years, decades of work. And we're not necessarily providing the same opportunities for junior developers to build that expertise in a market where so much work is being delegated to AI and to agents. And so there's this really interesting and difficult point in time where the rise of AI code really puts extreme pressure on having highly expert, fast-moving teams that do a fairly modest amount of code review compared to what happened before, and then rely on different sorts of signals that work with the velocity that people are shipping out these days. And so that brings me back to doing something of a review on Peak. And so do I think that the Peak project was right? And so I'm going to go Pareto, 80-20. So I think in developing what we built around Peak, we very much built for some practices which are on the decline. People are doing less thorough reviews. Review time is really constrained. Although we've automated some of those steps, we're really just kind of pushing it into the contributors' inbox as opposed to the maintainers. And really, lots of projects are already moving at a much faster pace and are not thinking through some of those architectural questions. There may be limitations in ways in which it can't scale, but for a lot of projects, velocity is the goal, and that they really want to rely upon signals that are faster than any human can provide and operate at a scale beyond any human can provide. And they're fine with this sort of like clean room reimplementation, rip and replace. We don't care about the old learn rules. We don't care about the institutional knowledge. It's cargo culting. We're going to start over from scorched earth. I think that is kind of the future. However, I do think that within that future, there's a 20% that the Peak project was correct about, which is that there is such a thing as consequential computing. That is computing which has real-world consequences on things like healthcare, defense, government, and finance. And so I'm going to zoom in just on finance just for 1 second here because I think it's relatively clear. There are all sorts of circumstances in which the code that was written touches money that impacts society in a broader way that is heavily regulated. Some of those regulations have names like SR 11.7 or FRTB, or increasingly even the AI regulations, things like the EU AI Act. Across the EU, the US, the UK, there's a lot of different legal regimes. They all boil down to, under certain circumstances, you are accountable for the code you wrote. You are accountable for that financial model which dispensed capital, that made decisions about who to give capital to and who not to give capital to. If you don't have the ability to retrace your who made those decisions, you're still on the hook, potentially for huge fines and potentially for jail time and individual liability in some of those cases. And so the idea that we're going to have no one who has the journey of climbing the mountain in their head, being able to evaluate consequential computing circumstances that could blow up a rocket, that could crash a car, that could drop a drone out of the sky. I don't believe it. I think that there is actually still a place for us to use the power of AI coding, but then also really build expertise and understand that we built that expertise. But I don't think anyone's really doing that well yet. I think this is the new territory. I think this is the journey that we are on as an industry. I think the good news is, connecting back to our perhaps sobering news around shrinking team sizes, is the people who are successful in this journey are going to be, in some ways, engaged in doing deeper, harder work. It is legitimately and ubiquitously true that the coding AIs are taking away all of the routine, the drudgery, all of the boilerplate work that software engineers used to get employed for. The days of body shops are over. What we're talking about are really elite, targeted teams where people have the whole model of the business, the whole model of what the technology needs to do in their head. They can bring to bear extreme expertise, and when they can have a huge impact on the success of the organization through technology. I think that's where we're steering towards. I think the software engineering role is getting harder in ways that are actually pretty exciting. They really raise the bar. You're not going to be able to snooze through the next 10 years of being a software developer. You want to dive into the trenches, you're going to find that it's really, really challenging. But there are tremendous rewards for people who put in the time, the sweat, and they go on the hard journey. They put in the work, they climb the mountain, and they can see everything from the summit. The exciting future that stands ahead of us for the field of technology in the age of Gen AI code. I've been Jeff. This is Iterative Refinement. Be well.